Hello, Math 2 students. Today we're going to talk about the vocabulary words that we use to describe what we're doing when we are factoring completely, or solving a quadratic equation by factoring. The first thing that I talk about a lot are A, B, and C. What are A, B, and C when you look at an equation in standard form? So standard form is ax squared plus bx plus c equals 0. In my example, I have 8x squared plus 6x minus 7 equals 0. So the A, B, and C, the A term is 8. That's just the number that comes in front of the x squared is A. The B term is 6. That's the number in front of the x. And the C term is the constant term. On this problem, the constant term is negative 7. So that's when we're talking about the coefficients, the numbers in front of the variables. If we talk about each monomial separately, we can have 8x squared, and sometimes we call that the A term. Sometimes we call that the x squared term, and sometimes we just call that the first term. Another term that we might look at is the 6x. That monomial is called the B term because 6 is the B. It's also called the X term because that's the term that has just an X, no X squared. Sometimes we call it the middle term. And when we're dealing with foiling, sometimes we call it the outer term plus the inner term. And then finally we have the negative 7. Sometimes that is called the C term. Sometimes that's called the constant term. Sometimes we call that the last term. So when you hear me using these words in class, I'm just identifying a certain part of the problem, a certain part of the monomial, or a certain monomial. The greatest common factor, the greatest number that will divide evenly into every term of the polynomial. But not just the biggest number, we also want to know the largest quantity of x's that will go into each term. So when we started learning this, we started out by doing factor trees and writing down the prime factorization. So we had 2 times 6, which is 2 times 3 times x times x times x times x. This will be 3 times 9, and 9 is 3 times 3, and we have 3 x's. And this is also 3 times 3 times 3 with 2 x's. So those are the prime factorizations of each of those monomials that make up our trinomial. Now what we want to look for is what they have in common. I'm going to start with the x's. So we have x squared in this term. We have x to the third in the middle term, but it at least has an x squared. And we have x to the fourth in the first term, but it at least has an x squared. So every term has at least 2 x's, so every term has at least an x squared. So our greatest common factor will have an x squared in it. All right, now if we look at the numbers, this term has 1, 3, this term has 1, 3, and this term has 1, 3. Now, the B term and the C term have more 3's, but they at least have 1, 3 in common. So our greatest common factor is 3x squared. Some students don't do this problem that way. They would find the greatest common factor by just thinking in their head, what is the biggest number that goes into 12 and 27 and negative 27? And the biggest number is 3. Then they would look at the exponents on the x's, and they would see that the first term has 4, the second term has 3, and the third term has 2. So they all have at least 2 x's. And then just from inside their head, they would write down that the greatest common factor is 3x squared. So you could do the prime factorization like I did first, or you could just find the greatest common factor by using what you know about multiplication and division and exponent rules. Another word that you hear me saying a lot in class is the remaining polynomial. That's the polynomial that's left after the greatest common factor has been divided out. So we found out on the previous problem that the greatest common factor is 3x squared. How do we find out what trinomial is going to go in the parentheses? that will be the remaining polynomial. So what I need to do is divide every term by the greatest common factor. So when I just look at the numbers, I have 12 divided by 3, and so that will give me 4. I have 27 divided by 3, that'll give me 9, and I have negative 27 divided by 3, which will give me negative 9. Now, when I look at the x's, in all of these cases, we've learned how to do this already. There are multiple occurrences of x. One is in the numerator, one is in the denominator. So the rule that we learned when we were learning how to simplify monomials was that we should subtract those exponents. So we will have 4x to the second, we will have 9x to the unwritten first, and we will have negative 9x to the 0, and anything to the 0 power is 1, so we'll just leave a negative 9. Now that we know that our remaining polynomial is 4x squared plus 9x minus 9, we need to break it up into its binomial factors. The two binomials that, when we multiply them together, will give us 4x squared plus 9x minus 9. In order to do that, we're going to have a 4x and an x, and we're going to have a 3 and a 3. And so these are our binomial factors. Factoring completely. Factoring a polynomial until there is no way of factoring it further. So if possible, in every polynomial, you want to take out the greatest common factor. It's not always possible, but you need to try. And then after you take out the greatest common factor, if possible, you want to change the remaining polynomial into its binomial factors. That is called factoring completely. The difference of two squares. This is an important thing to know, because if you can recognize that you're dealing with a difference of two squares problem, you can get the binomial factors immediately. So in order to have a difference of two squares, you need a binomial. It has to have a minus sign in between the two terms. The first term has to be a perfect square. The last term has to be a perfect square. And if your polynomial is a difference of two squares, then it will factor into a sum and difference pattern. Here's an example. If you have x squared minus 25, it's a binomial. There's a minus sign in between. The first term has an a value of 1. 1 times 1 is 1. It's a perfect square. And the last term is 25. 5 times 5. It's a perfect square. So we know that when we factor this into its two binomial factors, it will be a sum and difference pattern. So we'll have a plus and a minus. We'll have x times x is x squared. And 5 times 5 is 25. Done. A perfect square trinomial. Again, another way to instantly know what your binomial factors are. If you're looking at a polynomial and it's a trinomial and its first term is a perfect square and its last term is a perfect square and its last term is positive, if that's what you're looking at, then your polynomial is a perfect square and it will factor into a binomial squared pattern. So an example of that would be x squared minus 12x plus 36. It's a trinomial. Our first term has an a value of 1. That's 1 times 1. Our last term is a perfect square. 6 times 6 is 36. And our last term is positive. So we know that both of our binomial factors will be exactly the same. So we will write our final answer as a binomial squared. Guess and check by FOIL. This is the method that you have to use when you don't have a difference of two squares and you don't have a perfect square trinomial. You just have to find two factors that multiply to the a term and two factors that multiply to the c term. So for example, if we have 24x squared minus 22 plus 3, we know that 24 could be 1 times 24, 2 times 12, 3 times 8, 4 times 6. all of those factors could multiply to 24. And we know that 3 is 1 times 3. So we need to find factors that multiply to 24, that's our A term, and factors that multiply to C. Now, the way that we can find out whether it's 1 and 24, 2 and 12, 3 and 8, or 4 and 6 is by FOILing. So we're going to multiply the binomial factors using FOIL, and if the outer terms and the inner terms combine to form the B term of our original problem, then the binomial factors are correct. So we used 4 and 6, and we know that it's going to multiply to 24x squared. So we know that this part is right because we looked at the 24 when we wrote down 4 times 6. And then we know that this part is right. Negative 1 times negative 3 is positive 3. That's why we chose negative 3 and negative 1. Now the way that we check the problem is when we multiply the outer terms and get negative 4x and the inner terms and get negative 18x. If these two terms combine to form our B term, we know we've done the problem correctly. We have the right binomial factors. So this would make negative 22x. And when we look at our original problem, that is our middle term, so we know that we did it right. When factoring, prime numbers are your friend. Prime numbers are numbers that only have 2 factors. So 2 is a prime number because it's 1 times 2. 3 is a prime number because it's 1 times 3. 5 is a prime number because it's 1 times 5. And 7 is another example of a prime number because it's 1 times 7. Each of those numbers only has 2 factors. That always makes factoring easier. Composite numbers, on the other hand, are more difficult to deal with. If you have a 4, it could be 1 times 4 or 2 times 2. If you have a 6, it could be 1 times 6 or 2 times 3. If you have an 8, it could be 2 times 4 or 1 times 8. So prime numbers should make you smile when you're factoring. Composite numbers make the problem more complicated. All right, one thing that you want to avoid when you're factoring is you want to avoid binomial factors with a greatest common factor in that binomial. If the first term and the last term of a binomial factor can be divided evenly by the same number, then a mistake has been made earlier in the problem. The mistake probably is you took out the wrong greatest common factor. You used a common factor, but not the greatest common factor. So quickly in this example, we have 2 as the greatest common factor, and then 2x squared minus 6x minus 36. Over here, we're going to do the problem a different way. We're going to say the greatest common factor is 4, and that'll leave us with x squared minus 3x minus 18. So this is 2 different ways of doing the problem. One of them, the one on the right, is going to be correct. The other one, the person has made a mistake. But I will show you how to identify the mistake when we get there. So next, we need to break our remaining polynomial into its binomial factors. So this will be 2x plus 6, and this will be x minus 6. Over here, when we break it into its binomial factors, we'll have x plus 3 and x minus 6. Now, this is the important part. Right here, we know that we've made a mistake. That's what you want to be looking for, because that binomial, 2x plus 6, has its own greatest common factor. 2 can go into 2x and 2 can go into 6. If that ever happens to you, or if you create a binomial like that, you know you're doing the problem wrong, because all of the greatest common factors should have been taken out at the beginning of the problem. So do not create binomial factors that have greatest common factors in them. At the beginning of the chapter, when we learned about greatest common factors, we were always taking out greatest common factors that were numbers, and we never had to worry about variables. But remember, when we learned to solve equations, we learned that if you have a variable in the front, then you have a solution of zero. So now that we're factoring and our greatest common factors include x's, there's nothing wrong with that. That just means that that kind of equation has 0 as a solution. The zero product property. If the product in a multiplication problem is 0, then at least one of the numbers being multiplied is 0. The zero product property is used to find solutions to equations in factored form. So in this example right here, we're multiplying 2x times x minus 7 times 5x plus 3, and our answer is 0. So if those three things are being multiplied together and the answer is 0, we know that at any time, one of those three things must be a 0. So to start with, we have learned that if you have a variable in front of the parentheses, that will give you a solution of 0. And that makes sense because what will make 2x, that part of the problem, into a 0? Well, if x is 0, then 2 times x will be 0. And that front part of the problem, the greatest common factor, will be equal to 0. Now, when we go to the next part of the problem, we have x minus 7 equals 0. The coefficient in front of the x is an unwritten 1. And what we learned was that the solution will be the opposite, because the opposite will make that binomial equal 0. So if x equals positive 7, then that binomial will be 7 minus 7, which is 0. And finally, on our last binomial, it has a coefficient of 5. And so whenever there's a coefficient that's not an unwritten 1, in order to solve, you need to write this equation and solve the equation. So in that last binomial, if we replace the x with negative 5/3, we'll have 5 times negative 5/3 plus 3, and that will equal 0. So that's the way to make that binomial into 0. So that's how we get our third solution.